In this video we are going to learn about the electrochemical series, what it is and how it is used. In the video Measures of Electricity we found out that different combinations of metals produce different voltages, and this depends on how strongly the metal could force its electrons to move across a cell. The electrochemical series is a list of metals and other substances arranged in rank order of how easily the atoms may lose electrons. The further apart the metals are in the electrochemical series, the higher the voltage is produced across the cell. Electrons flow along the wire from the metal higher in the electrochemical series to the metal lower down. The electrode potentials are arranged in the substance's ability to donate its electrons, that is, how easily they are oxidized. All of the values are measured in volts. What do you notice about hydrogen's voltage, and what is the significance of this? Pause the video and continue when you are ready. The answer is that hydrogen has an electrode potential of 0 volts. The significance of this is that it acts as a reference. All other electrode potentials are measured against this value. It's a bit like the heights of a mountain, which are relative to the sea level. The sea level is given a height of 0 meters. Using the electrochemical series, can you predict the direction that the electrons will travel towards for the following pairs of metals? The electrons always move from the metal with the more negative electrode potential to the more positive electrode potential. Pause the video and continue when ready. For A, the answer is the electrons move from potassium to hydrogen. For B, the answer is the electrons move from zinc to copper. And for C, the answer is the electrons move from lead to mercury. You can also use the electrochemical series to predict a displacement reaction when a metal from the electrochemical series is mixed with ions of a metal lower down in the series. The atoms of the more reactive metal push their electrons onto ions of the less reactive metal. Let's consider what happens when an ion now is placed in a solution of copper sulfate. The higher up metal in the electrochemical series is the one that always displaces the ions of the lower down metal. Metals lower down in the series cannot displace more reactive metals from their solution. You can use this idea to predict whether a displacement reaction will occur. Here's a challenge. Can you explain why the ion now formed a copper coating when it was placed in a solution of copper sulfate? Pause, think and continue when ready. The correct answer is that the ion is higher in the electrochemical series, so it gave away its electrons to the less reactive copper-2 ions in solution. The ion is oxidized as shown in the equation. The copper is less reactive, so its copper-2 plus ions are forced to accept these electrons. This is called reduction. As a result, copper metal is produced and coats the now, as shown in the reaction. These two processes happen simultaneously in something called a redox reaction. In summary, the electrochemical series contains electrode potentials measured in volts, which are compared to hydrogen. The greater the difference between the two substances in the electrochemical series, the more readily the electrons move from the more reactive metal, i.e. the more negative value, to the less reactive metal, i.e. the more positive value.